Hey everyone, and welcome to The Explainer. I am so thrilled you're here today. We are taking on a topic that honestly might sound a little like dry academic math at first glance, but I promise you, it is essentially the ultimate Marie Kondo method for your data. We're going to master the art of database normalization. By the end of this explainer, you're going to know exactly how to take a chaotic, cluttered data set and transform it into a sleek, optimized, and just beautifully structured relational database. But before we start organizing, let me ask you a question. Have you ever accidentally caused a catastrophic database crash just by updating a single address? Or, I don't know, maybe you deleted one employee record only to realize you actually just deleted an entire corporate office branch from your system. If you have, trust me, you are not alone. These are the hidden dangers lurking inside poorly designed databases. Okay, let's dive into this. To reach data perfection, here's our roadmap for today. First, the messy data problem. Second, rules of functional dependency. Third, first normal form. Fourth, second normal form. Fifth, third normal form. And finally, number 6, the power of normalization.
Let's kick things off with Section 1, the messy data problem.
It is literally amazing how quickly a simple spreadsheet can just turn into an absolute monster. Imagine a table called Staff Branch. On the surface, it seems totally fine. It's got staff names, positions, salaries, and the branch they work at. But when you look closer at the branch addresses, the exact same branch details are dangerously repeated for every single staff member working there. I mean, if 50 people work at branch B003, that specific branch's address is manually typed out 50 separate times. This is what we call data bloat, and it's incredibly dangerous.
That bloat creates what database designers call update anomalies. These are basically 3 terrifying ticking time bombs. First up, the insertion anomaly. Imagine trying to add a brand new branch that doesn't actually have any staff assigned to it yet. Because the staff number is the primary key of our table, we literally can't create a row for the branch without a staff member. Second is the deletion anomaly. If we delete the last staff member at a branch, say Mary Howe quits, we accidentally delete the entire branch's address from the database too. And finally, the modification anomaly. If a branch moves across town, we have to go in and update the address on 50 different staff records. If we miss even one, boom, our database is instantly corrupted with conflicting information.
So how do we defuse these time bombs? We need a cure. And that brings us to Section 2, the rules of functional dependency.
The absolutely crucial point here is understanding functional dependency. It's really just the logic of, if I know X, I automatically know Y. X is what we call the determinant. If you give me the determinant, I can absolutely 100% guarantee the value of the other attribute. It's a strict one-to-one relationship from the left side to the right side. Now think about the difference between a true functional dependency and a false one. If I know your unique staff number, I can automatically determine your exact staff name. That is a true functional dependency. But think about the flip side. If I only know your staff name, let's say it's John White, I cannot guarantee your staff number. Why? Well, because there might be 3 different John Whites working in the company. Name does not functionally determine staff number. Getting your head around this one-way street is the real key to organizing messy data. So let's put that key to use. Section 3. First normal form, or 1NF. Before we normalize anything, we have what's called unnormalized form, or UNF. And honestly, think of UNF as a hoarder's house. It's just full of messy, repeating groups of data crammed into single rows. Imagine a single client row that just lists 5 completely different rental properties all crammed into one single cell. You can't search it, you can't sort it, it's totally unmanageable. To achieve first normal form, we really just followed 2 simple steps. Step 1, we identify all those messy repeating groups of data. Step 2, we flatten the whole table out by filling in the empty columns. We're just making sure that at the intersection of every single row and column, there is one and only one value. When we apply those steps to a messy data set, we get a first normal form table. We fix the repeating groups. Every row and column intersection now has a single atomic value. But wow, there is still a ton of repetition. We're repeating the client's name and the property owner's name over and over and over again. So 1NF fixes the formatting, sure, but it still leaves us with a lot of scary data redundancy to solve. To solve that redundancy, we need to level up. Let's move to Section 4, second normal form, or 2NF. Here is the core rule of 2NF. The table obviously has to already be in 1NF, and every non-primary key attribute must be fully functionally dependent on the entire primary key. In a lot of databases, the primary key is a combination of two things, like a client number and a property number. But a client's name only depends on their client number, right? Not the property number. That is a partial dependency, and in 2NF, that is totally illegal.
I'm going to say it loud and clear. No partial dependencies. Every single piece of data in a table must depend on the whole key, and nothing but the whole key. If an attribute only depends on a tiny piece of the primary key, we have to kick it out and give it its own table.
By strictly enforcing that rule, we actually divide a giant bloated table into 3 clean 2NF tables. The client name gets its own client table. The property details get a property owner table. And a rental table sits right in the middle, tracking exactly which client rented which property. Just like that, we've eliminated massive amounts of repetition and moved one huge step closer to data perfection.
But we aren't quite there yet. We need to move to our final cleaning stage, Section 5, Third Normal Form.
This is where we eliminate the absolute last hiding places for those update anomalies we talked about earlier. To reach 3NF, we have to completely destroy something called a transitive dependency. What is that? It's basically when a non-key attribute secretly depends on another non-key attribute instead of the primary key. For example, if you have a table where the primary key is property number, but you also have an owner name field, the owner name actually depends on the owner number, not the property number. The dependency is jumping through a middleman.
And that brings us to our final, absolutely unshakable rule of database normalization: no transitive dependencies. If a piece of data is secretly relying on another non-key piece of data, it's gotta go. It needs its very own table. So in practice, we take that 2NF property owner table we had and we split it. We extract the owner details into a completely dedicated owner table, and what's left behind is a pure property for rent table. By doing this, if an owner ever changes their name, we only ever have to update it in exactly one place, the owner table. We have finally achieved a perfectly modular, third normal form database.
Let's bring this entire journey together in our final section, the power of normalization.
Think about the contrast here. We started with a dangerous, bloated, unnormalized form, literally a spreadsheet just waiting to crash your system with insertion, deletion, and modification anomalies. Now we have an elegant 3NF architecture. Because we use primary and foreign keys to split the tables up, we've achieved what is mathematically called the lossless join property. That just means we can safely recombine these tables at any time to get the full picture without ever losing a single drop of data and completely avoiding all that redundant bloat. Which brings me to a final thought for you to take away today. Take a really hard look at how you manage information. Are your own unnormalized spreadsheets secretly hiding a ticking time bomb of data anomalies? The next time you find yourself copying and pasting the exact same address into 50 different rows, I want you to remember this explainer. Remember functional dependencies, banish those partial and transitive dependencies, and transform your data into elegant, bulletproof tables. Thanks so much for joining me today, and happy organizing.